The rules for even and odd are over here on the right. So if you see even, f of x has to equal f of negative x, and odd, negative f of x equals f of negative x. So you're given the function f of x, so I'm going to start by seeing if it's even by plugging in negative x. All right, so what you do is you plug in negative x everywhere you see an x. And then I'm going to raise that to the 5th power. Okay, because I'm doing x to the 5th power, so I'm replacing the x with negative x, which means I'm doing negative x to the 5th power. So then minus 7. And now I'm going to take that x squared and replace the x with negative x, and I'm going to square that. Plus 10. There's no x there, so I leave it. All right, so let's work out f of negative x. So if I work out f of negative x, well, if I have a negative raised to the 5th power, that's going to give me a negative, isn't it? So then, what that's going to make this is negative x to the 5th. Now, if I have a negative raised to the 2nd power, that's going to give me a positive. Times this negative 7, however, will leave me with negative 7x squared there. So negative 7x squared, and then plus 10. All right, so if you look at what we have here, you can see that these two values, f of x up at the top and f of negative x, are not the same thing. So you see here I have a negative x to the 5th, but here I have a positive x to the 5th. Everything else matches up, the negative 7x squareds and the positive 10s, but our x to the 5ths are not the same. So then that being the case, we would say that it's not even because, and then let's state the rule, f of x does not equal f of negative x. All right, so then the next rule that we're going to test for is odd. Well, odd says negative f of x equals f of negative x. Well, we know what f of negative x is. Let's steal it from the first part up there. So we know that f of negative x is negative x to the 5th minus 7x squared plus 10. Okay, now let's be a little careful here with this rule here. All this is telling you to do is negate your f of x, which is your original function. So go back to your original function, and we're basically going to negate everything. So here's our original function right here, and we're going to negate all those signs. That's really all that is. All right, so negative f of x is going to be negative x to the 5th plus 7x squared minus 10. All right, well, you look at these and you can see that those don't match up either. So we would say that this is not odd because negative f of x does not equal f of negative x. So obviously then if we look at this and we look at this, we can obviously say that this is a neither. Now the other way to do this as a check anyway, because it does say determine algebraically, so we do need to show all the work we just showed, but as a check, I would plug the original function into your calculator. Now remember, if something is even, it's symmetric with respect to the y-axis, so it will fold over the y-axis. And so if you plug in that f of x into your y equals and go to your graph, you'll see that it does not fold over the y-axis. Same thing with odd. Okay, odd is symmetric with respect to the origin. So in other words, if you turn it upside down, turn it 180 degrees, you should have the same picture right side up as you do upside down. And you don't. So therefore odd would not be the case either. Okay, so you definitely want to do a check, but again, because the directions say algebraically, that's all that it is when you put it in the calculator, is just a check. Now remember the rules from part A, so the same rules are going to apply, so I'm going to start by proving even. And again, remember, as a check, you can plug h of x into your y1 and see if it folds over the y-axis. If it does, it's even. And you can see whether or not, if you rotate it 180 degrees or turn it upside down, is it the same picture right side up that it is upside down? All right, so I'm going to go straight for the even, which means everywhere you see an x, I'm going to replace it with a negative x. All right, so let's just be a little careful here. This negative right here is this negative right here. Then where I see an x now, I'm going to replace that with a negative x, and I'm going to cube that. Okay, so you just want to be a little careful with that. So I'm going to go like this, and I'm going to cube it. Okay? All right, I see plus x, so I am going to write plus and then negative x, which kind of seems weird to write, but we'll fix it in the next step. And then in the denominator, I have 2 and a negative x. Okay. So let's look at this. So let's be, again, a little careful right here. I know that when I have a negative and I cube that, that's going to be a negative. However, then I'm going to have another negative here, which is going to make a positive, right? Okay, so that's going to give me a positive x cubed. Then I have minus x here and over negative 2x. Okay, now there's something really interesting about this. You should know that if you put this in your calculator, that this is an even function. It's symmetric with respect to the y-axis. It doesn't look like it though, does it? This here, this fraction, doesn't look like this fraction. But let's take note. That's a negative x cubed, and this is a positive x cubed. This is a negative x. I'm sorry. This is a positive x. This is a negative x. This is a negative 2x. Oh my gosh, I'm not doing too well this morning. This is a positive 2x. This is a negative 2x. Do you notice all the signs are the opposite? Very interesting, right? So there's a bunch of ways that we can go about this, but what I'm going to do in my next step, is I want to take my h of negative x. And you know how like when you have a fraction, I'm going to put it up here on the top right. If I have negative 2 over 5, I could write it like that. I could write that negative kind of in between the fraction, or I could write that negative in the denominator, couldn't I? So the negative can go in any one spot. So I'm going to look at the fact that I have a negative in the denominator right here with the 2x. So I'm going to try to get this 2x to look like it's positive, like it is up here. So I'm just going to, for now, I'm going to take that negative and I'm going to put the 2x here, and I'm going to put the x cubed here and minus x. So do you see that that is still the same value as what I have here? I just took this negative and I put it right there. Okay? It's kind of like factoring out a negative. Now, what I'm going to do is, can I take this negative, and instead of putting it here, like it is up here, right? Couldn't I take this negative and distribute it through to the numerator? In other words, put it up in the numerator like I have up here. And the reason why I want to do that is, watch this. So if I do that and I take this negative, let me do this in a different color so you can see it. If I take this negative and I distribute it through, right? So I took it out of the denominator and essentially just moved it up to the numerator instead. But if I do that, what it does is it makes that x cubed a negative x cubed, and it makes that negative x a positive x, and the denominator is 2x. And now, if you look at what you have, your original h of x here and your h of negative x, look at that, they're the same thing. And that's why I did that. So because h of x equals h of negative x, then we know h of x is even. So it's asking for you to find the inverse for the function. So remember, when you have an inverse, you're going to switch your x and your y values. So we have f of x, which is the same thing as y. So I'm going to turn that into x because I'm trying to find its inverse. And then I see that I have x plus 3, so I'm going to replace the x with y plus 3. And the denominator also has an x in it, so I'm going to replace that with y. Okay, so I've got two fractions set equal to each other. So I'm going to cross multiply this way, and let's see what I get. So I get 2xy plus x, and then I'm going to cross multiply this way, and that is going to give me y plus 3. All right, so the goal here is we want to find the inverse, right? Well, we did just switch the x and the y, so we did find the inverse. But if you look at the four choices, all four choices, pretty much remember, this means y equals, y equals, y equals, y equals. It's just the inverse equation. So this is the y equals in the inverse equation. So we want to try to get this y by itself, and it's not right now. So how about I'm just going to move everything that contains a y over to the left, and everything that doesn't contain a y, I'm going to move over to the right. So those are going to disappear, and those are going to disappear. Okay, so I don't have like terms here, so I'm just going to write 2xy minus y for right now. And the same thing on the right-hand side. I'm going to write 3 minus x for right now. Okay, so the left-hand side, they both have y terms, so I can factor that y out. And if I do that, I get 2x minus 1. And over here, I have 3 minus x. Okay, so my goal is still to get the y by itself, so I'm going to divide by what's attached to that y, which is 2x minus 1. And then I have y equals 3 minus x over 2x minus 1. Now, technically, this is the inverse equation, right? So we don't want to say y equals, so we want to say f inverse of x equals. And this is your answer. Now you go up there, you look at your choices, and you see that that is choice 2. Okay, so we're trying to describe the transformation. Now remember, when you have a number inside parentheses, which technically, I guess, absolute value, you really are inside parentheses here. Remember that this is a shift to the left or to the right. But remember, when something's inside parentheses, it's actually in the opposite direction of the sign. So in other words, this is a minus 7, so we're actually going to shift to the right 7. And when a number is outside the parentheses, like we have right here, we're actually going to just go up or down. And that goes in the same direction as the sign. So since it's a plus 6, that means it will be going up 6. Okay, I'll write all this down in a second. And then lastly, let's look at this negative. Okay, we are negating the entire thing. So when we're negating the entire thing, that is going to be a reflection in the x-axis. All right, so let's write this stuff down. So, well, we can kind of go in any order, but I'm going to say that we're going to go 7 units right. Oh, that's supposed to be an I, sorry. 7 units to the right. We're going to go 6 units up. And we are going to reflect over the x-axis. Now, remember, as a check, you can put this into your calculator. So you can go to your y equals, and you can plug in this, and you can plug in this, and you can see the change that occurred in our second equation here and compare it to the first equation. You should do that as a good check. Now, just remember, here's the $1 million question. Do you remember where the absolute value button is in your calculator. So if you do this now, and pause me if you need to, get your calculator, and if you go to y equals, and you hit the math button, an arrow to the right to num, and you'll see it right there at number 1. It says ABS. That's your absolute value button. If you hit that, it'll go straight into your y equals, and then you can type in whatever you need. So number 4 is the same as number 3. Again, I would suggest that you put f of x into your y1 and put g of x into your y2, and that would give you a better idea of what's happening here. Okay, so here's f of x in blue. And if you look, it's an upward pointing parabola, and our y-intercept right there is at 4. And here's g of x in red, and you can see here that we definitely moved from here. We moved over to the left, and we moved down. So remember that this number inside the parentheses is a horizontal shift, but in the opposite direction of that sign. So since that sign is positive, we're actually moving to the left 3 units. Right? So that's the first thing we're doing, is we're moving to the left 3 units. Now, let's be a little careful here on the second part, because we've got a shift. We're all the way up here at 4, rather, and then look at what happened. We went all the way down to a -5, and ooh, I just noticed something. This should be a -5, shouldn't it? Oops, now that looks great, doesn't it? Sorry about that, but this is a -5. If I try to play with it, it's going to look worse. So that's a -5 right there. You know what I'll do is I will, oops, I'm not doing too well today. Let's put -5 right there so you can see that that's what that is. All right. So getting back to my point being is we started at 4 and then we went all the way down to -5. So that, be careful, is a shift down, but it's a shift down of 9 units. Okay, because we went from a +4 to a -5. All right, so they're asking you to determine the, average rate of change. So let me try to underline the correct thing. There we go. And between the 6th and the 14th hour. So here's the 14th hour right here. And the 6th hour, let me see if I can do this, is right up there at the max. So remember, average rate of change is basically just your slope formula. So y2 minus y1 over x2 minus x1. All right, it doesn't really matter in what order you go in. So I'm going to start with my y2 being the y value at 6, which is 120. So 120 minus the y value at 14, which is 0, over the x value that corresponds with the 120, which was 6, minus the x value that corresponds with the 0, which was 14. All right, so let's do the math. So we have 120 over -8, and when we divide that, that's a -15. Okay, so what does that represent? That's the bigger issue, because if you look at the question, it says explain what this means in context, in context of the problem. So the manager is analyzing shoe sales, and he collects data for the, here we go, number of pairs of shoes sold each hour over time, a 14-hour time period. So you can see that at time 0, he's sold 48 pairs of shoes. The amount that he sells increases till time 6. And then after that, the amount that he sells decreases. Okay. All right. So let's look at what we have here. Because what we have here is a -15. So do you think that his sales are increasing or decreasing? They should be decreasing, right? Because that's negative. So remember, whenever we're doing a average rate of change. We want to say on average or something to that effect. So I'm going to say on average, his shoe sales are decreasing, right? Okay, so we can say shoe sales decrease. Oop, I'm going to try and squeeze that in. At a rate of 15, and we're talking about pairs of shoes, so 15 pairs of shoes. And our time is in hours, right? So per hour. And we need to be specific as to what time frame we're referring to. So that would be between hour 6 and hour 14. All right, so obviously you should be reading the question. It does say round to the nearest tenth. It does not ask us to show algebraic work, so I'm going to do this in the calculator. So I'm going to take the first equation, that y equals 2 to the x plus 3, and I would suggest that you put that in your y1 and get a picture. So your picture is going to look something like this. So this is the y equals 2 to the x plus 3. Okay, and this is intersecting the y-axis at 3. All right, so then after that, I would do the same thing. I go into my y2, and I would plot y equals 0.5 to the x. Okay, so when you plot y equals 0.5 to the x, it looks something like that. So this is y equals 0.5 to the x. Okay, so we basically want to determine the best approximation of the intersection of the flight paths. So you're going to do second calc, intersect. So we want to find this point right here. So when you do second calc intersect, now remember, you have both your equations in your y1 and your y2, and do a zoom 6. Okay, so when you do that, you're going to go second calc or second trace and go down to number 5. Look at in your calculator. Look at it in your calculator. Okay, so second trace, go down to number 5 where it says intersect. So you're going to see that blinking cursor. Remember, you want your blinking cursor to be to the left of this intersection point. So actually, your blinking cursor will probably end up being somewhere around here. Okay, so then after that, remember, you hit enter. And your blinking cursor is going to boot you to the second curve, which is going to be somewhere around here, my guess. And then you're going to scoot it off to the right and hit enter twice. And you'll get your intersection point. Okay? And it says determine the best approximation of the intersection of the flight paths, rounded to the nearest tenth. So you should end up with -1 point, and if you look at it in your calculator, it should say 7236, blah, 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 blah. So to the nearest tenth, that's going to be -1.7. And then your y value should say 3.3027, blah, 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 blah. And we're going to round that to the nearest tenth, and that would be 3.3. So this would be the best approximation. Okay, so number 7 is really asking the same question as number 6 was asking, except for one thing. Please be careful. Remember, when you see this, those are y values. So when they're asking you to determine the solutions, that's still looking for where the two graphs intersect, but they actually only want, oops, that's supposed to be an arrow. No, that really doesn't look like an arrow. All right, let's see if I can undo that a little bit. They only want you to have x values as your answer. Okay? All right, so you're going to graph this. So put g of x in your y1, Put h of x in your y2, and let's get a picture. So here's the sketch of g of x. Remember again, if you're looking for the absolute value in your calculator, hit Math, arrow to the right to Num, and you'll see it's right there at number 1. It says ABS, and hit Enter. All right, so here's the graph of g of x. Now I'm going to put the h of x in my y2 and get a picture of that. And there's roughly what h of x looks like. All right, so we're going to determine the solutions. Well, the solutions would be where the two graphs meet, right? So here's the one spot, here's another, and here's the last one. So just like in number 6, you're going to do second calc or second trace, go down to number 5 where it says intersect. Okay, so if we're looking for the first intersection point, your cursor should be blinking somewhere around here to the left of this intersection point. Then you're going to hit Enter. After you do that, move your blinking cursor, because your blinking cursor is going to be somewhere around here. You're going to move it to the right of the intersection point, maybe somewhere like right around here. And then you hit Enter twice. So when you hit Enter twice there, and remember we're rounding this to the nearest tenth because you should get x equals negative 2.2055. We're going to round that to the nearest tenth, and that should be negative 2.2. So there's your first intersection point. Okay, so let's do it again. So when you're doing it again, you've got to do second calc or second trace. Go down to number 5 again. All right. So your blinking cursor should be somewhere on this blue graph. So I want it to be to the left of this point right here, so I'm going to put it maybe right around here. You hit Enter, and then move your blinking cursor, because now it's got you somewhere on this graph, right? And I'm going to move it off somewhere to the right of this intersection point, so somewhere around here, let's just say. And hit Enter twice. So when you do that, it's going to give you x equals negative 0.7222, so on and so on. We're going to round that to the nearest tenth, so that's going to be negative 0.7. All right, lastly, third intersection point, which is all the way up here. So we're going to start over again. So second calc, second trace, go down to 5 to intersect, and your blinking cursor is going to be somewhere on your g of x equation, somewhere around here. We want it to be to the left, so let's get it maybe right around there. Hit Enter. It's going to boot you to this second curve, and then we want to be to the right, which would be somewhere around here. And hit Enter twice. Okay, so when you do that, you should get x equals 2.0687, blah, blah, blah. Again, we want to round that to the nearest tenth, so that would be 2.1. So here are your 3 x values of the intersection points. And so again, just remember, whenever you see these y values equal to each other, that means please give us the x values of the intersection points. 1, 2, 3. Okay? All right, parabola questions, let's always, always, always draw a picture. So draw this picture, and I'm at negative 3, positive 2. So there's my focus, and my directrix, I'm going to need to extend that a little bit, is 2, 3, 4, 5, 6. Okay, and actually, you know what? Let me do this. I like this better, I think. Let's make this in red, and our directrix is at y equals negative 6, and that's down here. I'm going to put that in red. Okay, so then let's figure out where the parabola is supposed to be. Well, remember, the parabola is never supposed to touch my directrix. It can't touch this line. So I know my vertex of my parabola has to be halfway between the focus and the directrix. So that would tell me then that my vertex is going to be at negative 3, negative 2, right here. Okay, and the reason being, again, is the distance from this blue dot all the way up to the red is 4, and the distance from this blue dot all the way down to the directrix is 4. Okay, the vertex has to be in the middle. But remember, my parabola can't cross over this line down here. So I know that my parabola can't open down. So in that case, then I know that my parabola is going to open up like that. Okay? And when a parabola opens up, remember that that's a y equals. So let's go over a couple of things. I know that my vertex is -3, -2. I also know that my p-value, and remember your p-value is the distance from the vertex to the focus, which is 4. Or it could be from the vertex to the directrix. That's also 4. So any way you want to look at it, doesn't matter. So we know that my p is 4. All right, we also know that this parabola opens up. So that means that's a y equals. And because it opens up, that's going to be a positive 1 over 4p. And then I know the formula is x minus h, that quantity squared, plus k. All right, so let's use that formula and let's get it. So I've got y equals 1 over, now I know my p is 4, so 1 over 4p would be 16. Okay, now this x minus h, remember this is the x coordinate of the vertex. But I'm going to have x minus -3. I'm going to repeat that again. So I'm going to have x minus -3. So isn't that really x plus 3? So x plus 3. And then plus whatever k is. And remember the k is simply your y value here. So plus a -2. And I don't really like to write plus a -2, so I'm just going to write -2. And there's the equation of your parabola. Okay, so we're given the equation of the parabola, and we have to find the coordinates of the focus and the equation of the directrix. But before I can do that, I need to get this equation in the correct form. So remember we've talked about in class where we try to isolate the variable that does not have the square term. So in this case, it's the x that doesn't have square term. So I'm going to start by dividing everything by a -16. So that's going to give me x plus 2 equals. Now remember, we do like this to take the form of the 1 over 4p. So I'm going to take that -16 and write it as a fraction. So it'll be 1 over -16. And then we've got y minus 5, that quantity squared. Okay, so we're almost there. So we need to move that 2 over. And then we have our equation in the correct form, right? So we have x equals -1 over 16, y minus 5, that quantity squared, minus 2. All right, so let's look at this. Because it's an x equals, we know that our parabola is going to open left or right. And because our 1 over 4p is negative, we're going to open to the left. The next thing we need to look at is our vertex. So our vertex is going to be represented using this -5 and this -2. Now remember, this -5 corresponds to the y value. So this is the x value. All right, so let me talk about that a little bit more. So for my vertex, my x coordinate is going to be -2. Because remember, whatever the sign of the number is on the outside of the parentheses, that would be your x coordinate. When it's inside the parentheses, remember we changed this sign. So the y value is going to be a +5, not a -5. Okay, so I'm going to repeat that one more time. Whatever the number is that's out here, whatever sign corresponds with that, will stay. So that's why this is -2. Whatever number is inside the parentheses, whatever the sign is, we change that sign to the opposite. And because this says y inside the parentheses, this corresponds to a y value, which then, therefore, this has to be the x value. All right, so now remember, down here, the formula is 1 over 4p. So I'm going to divide this by 4 to get my p-value. So then I know that my p is going to be 4. Okay? All right. So next, I think probably the easiest thing to do is to draw a picture. So I'm going to draw a picture. And I've got -2, 5. So -2, 1, 2, 3, 4, 5. So here's my vertex. Remember I said that it opens to the left, and it opens to the left because, again, it's an x equals, so it's got to be left or right. And because the 1 over 4p is negative, that means that it opens to the left. All right, so it's going to go like that, right? All right, so now next, we need to find the focus and the directrix, right? Well, we know the p is 4. So then what I can do is I can go, actually, let me do this first. I can go 4 units to the left, 1, 2, 3, 4, and 4 units to the right. So let me just point this out again. So I'm going to go from here, which would be, where's my vertex again? -2, 5, right? So at -2, 5, and I'm going to go 4 more units this way. And then from -2, 5, I'm going to go 4 more units that way. Okay? All right. So if I move 4 units to the left, that's going to bring me right here. And the coordinates of that point, I'm going to write them down here below, but the coordinates of that point then would be negative, let's see, we've got 2, 3, 4, 5, 6, right? So -6, 5. And that would be your focus. And then if I go 4 units to the right of the vertex, that would give me my directrix, and that is x equals 2. So x equals 2 is my, make that look like an I, directrix. And here are your answers. All right, so I just want you to take a look at what I did here. So I did 2 things. The first thing that I did was I took this +2 and I moved it over to the right by subtracting 2. And that's how I got this 72 here. Okay, so again, I just -2 here, -2 here, and I got 72. The other thing that I also did was I reordered these. So I put the x terms together right here, and then I put the y terms together right here. Okay. Now, if I have to determine the center and the radius of a circle, I know that I'm going to do completing the square. But when you do completing the square, remember you want your lead coefficient to be a 1. So I'm going to take all of this and I'm going to divide it by 4. So if I do that, I'm going to get x squared minus 6x. Now remember, with completing the square, we're going to have a box plus then y squared plus 18y. And then again, I'm going to have a box. And this is going to equal 72. Oh, not 72. What am I saying? I got to divide that. Ooh, I'm so glad I made that mistake. I have to divide that also by 4 as well. So that's actually going to give me, what, 18 as well, right? Okay, and then if I have the 2 boxes on the left, remember I need to have the 2 boxes on the right. Okay, so let's talk about the boxes. So basically, remember we take half of this term that's attached to the x, the constant attached to the x, which is a -6. We take half of that, which is -3, and we square it. So if we half -6, we get -3, and if we square that, let's use a different color here. I'm going to get +9. And so that means over here in the box on the right, I'm also going to write +9. All right, let's go to the next term. So now we have the y's, right? Do the same thing. Go to the term that contains the y, look at the constant in front, and we're going to half and square. Okay, so we're going to take half of that 18, which is 9, right? And then we're going to square that. So I'm going to get 81. So I'm going to put plus 81 in here and plus 81 in here. Okay, so now remember at this point then, we take everything associated with the x values, and essentially what we're doing is we're factoring them. And we should get two binomials that are exactly the same. Now we can always do the cheater method, and if we just take half of this number, I'll show you what I mean. And I mean, I know you've done this, or you should have done this already, right? So I'm going to write x minus 3, that quantity squared. Okay, so because, again, let me explain. If I factor this out, I'm going to get x minus 3 times x minus 3, which really is just x minus 3, that quantity squared. However, we can cheat and just take half of the b term, which would be a minus 3. All right, so let's do the next one. So the same thing here. So I have a plus, right? Okay, so I want to factor out this right-hand side here. And technically, when I factor this out, I'm going to get y plus 9 and y plus 9, which really then is y plus 9, that quantity squared. Now, if you want to do the cheater method, we take the b term, and we take half of this number, and we put it right there. Okay? All right, and then lastly, let's just take the right-hand side, and that's going to give us 108 when we add that. Okay? All right, so the question is asking us to determine the center. So remember, the center is associated with this value here and this value here, but remember we changed the signs. So my center is going to be equal to 3, comma, negative 9. So there's your center. All right, next I want to look at the radius. So remember that the radius is the square root of what's at the end, which is 108. Now, we can simplify that, so let's do that. So I know that that breaks down to, and remember, if you don't know, go to your y equals, do 108 divided by x, and look for the biggest perfect square. So I see it at 36 and 3. So then my radius is going to be 6 square root of 3. So here's my radius, and here's my center. So if I look at my 4 choices, I definitely see that they all have i's in them, so that's definitely quadratic formula. I would start by subtracting that 3 over, so I'm going to have to subtract 3 here and subtract 3 here. So that's going to give me 18 x squared minus 24x, and that's going to be, what, plus 87 equals 0. Those are kind of big numbers. So I would say, oh, wait a minute, is there a GCF in there? And there most certainly is. It's 3. So it makes it a little bit easier. So if I divide out that 3, I get 6x squared minus 8x plus 29 equals 0. All right, so let's go straight to that quadratic formula. X equals, so we've got negative b, which is 8, plus or minus, big square root. Now b squared. B squared is negative 8 squared. Now remember, whenever you square a negative number, it becomes positive. So that would be 64 minus 4 times 6 times 29. Put that in your calculator. That's supposed to be the 9. Put that in your calculator, please. And that is going to give you the square root of negative 632. And don't forget all over 2a, which is going to be 12. All right, so let's talk about the square root of negative 632. I'm going to just make a little detour up here, okay? I would put that in my calculator, y equals, just put in 632 divided by x, and I see that it's 4 and 158. And look, guys, you really can cheat because you know, look at your 4 choices. They all have the square root of 158. So you know 158 goes into 632. Now, don't forget also, though, when we have a negative under the square root, what does that mean? That means we're going to have an I on the outside. Okay, so I know that that's going to break down to, and I'm just going to put the I, or the negative, with the 4, because that's the perfect square, and 158, right? So I know the square root of negative 4 is 2I, and then I'm going to have the square root of 158. Okay? All right, so let's go back down here. So I have 8 plus or minus 2I times the square root of 158, and then that quantity divided by 12. All right, now you see the 4 choices are in A plus BI form, so what I need to do first is let's tackle this 8/12. So I know that 4 goes into both of those, right? So 4 goes into 8 twice, and 4 goes into 12 3 times, plus or minus. All right, so now let's look at the 2 over 12. Well, I know 2 goes into both of those, right? So 2 goes into 2 once, so that's just I radical 158. And then 2 goes into 12 6 times. So here's our answer. Now let's see what answer choice that would be. So if we go up, we look at it, and we see that it is choice 4. All right, so we can look at this, and we can see that choice number 1 says the degree is odd. Now, let's be careful. If we read the question, it's asking which one is incorrect. So let's see if this function is odd. So we have direction changes that we're going to be looking for, right? So we're going up, that's 1. Down, that's 2. Up, that's 3. 3 direction changes. So that does mean that the degree of the polynomial is odd because we have an odd number of direction changes. So that is true, which means choice 1 is not the answer. Okay, let's look at choice 2. It says there's a positive leading coefficient. Now remember, when a function is odd, we start on the left-hand side and we see what is the function doing. It's going up. So that determines that we do have a positive leading coefficient. So again, that means this is true, choice 2, which means that can't be the answer. All right, let's look at end behavior here. So we have as x goes to negative infinity. So what that means is as we are moving to the left, the y value is going down. I'm going to repeat that again. So as we move to the left because that's negative infinity, the y value goes down because that's negative infinity. So let's see what happens. As we go to the left, do you see that the y value is going down? That's true. Let's double check the right side. So as we are going to the right, is the y value going up? So let's look at the far right-hand side of the graph. Look, the y value is going up. So that also is a true statement, so it can't be choice 3. All right, so obviously, process of elimination, we know it's choice 4, but let's just look at this. So it says that p of x is divided by x minus 2. So remember, if x minus 2 is a factor, then that means x equals 2 is a 0. And so if we look at what this statement is saying in choice 4, it's saying when p of x is divided by x minus 2, the remainder is 0. Well, doesn't that mean then that this will be a 0? At x equals 2, the graph will hit the x-axis here. So let's see if that's the case. Here's x equals 2. The graph doesn't hit the x-axis. It's all the way down at negative 4. So that's why the answer is choice 4. All right, so it gives you the function p of x, and it says which of the following must be true. So I always like to draw a picture. So here's the picture. I put it in my y1, and I just looked at where the graph hit the x-axis, because I know that at negative 3, at positive 1, and at positive 2, I have zeros, right? Okay, so it says which of the following must be true. Now, choice 1 and choice 2 don't even make any sense. 3 is a factor, negative 3 is a factor, like, we don't say that. Okay, so our factors technically for this graph here are x plus 3, right? Because I'm going to change the sign of my 0. And then that would mean I'd have x minus 1. Oops, let me make that look like an x. And then I would have x minus 2. Because again, I'm changing the sign of my 2 zeros here. So what I have here are the factors. So then I really see that the only answer that it could be is choice 3, because that has the factor x plus 3. Now let's just keep reading this though. So it says x plus 3 is a factor of p of x. That's true. Now let's watch this. Because p of negative 3 is 0. So this is saying when x is negative 3, I hit the x-axis. That's what that means. So let's look at this. When x is negative 3, look, I do hit the x-axis. So then I know that my answer is choice 3. Now I just want to talk for a quick second, though, about choice 4. X minus 3, first of all, it's not a factor. X minus 3 would be the graph hitting at x equals positive 3, which doesn't happen. Okay? All right, so we have the graph shown below. And if you look at that, what I usually, if I read the directions, they want me to write an equation, but in factored form. So I'm going to start by finding the zeros. And I know that I have a 0 at x equals negative 3, which means its factor would be x plus 3, right? And then I have a 0 at x equals 2, which means its factor would be x minus 2. But let's take a careful look at that factor. Do you see that the 0 here, do you see that the graph is tangent to the x-axis at x equals 2? For my students, remember we talked about the wiffle ball? So this is the wiffle ball hitting the door and bouncing back off. For those of you that don't know what I'm talking about, you should have learned that when you have a graph of a function and it's tangent to the x-axis, okay, what that basically means is we're going to square that factor. All right, and then lastly, I see that I have a 0 at x equals positive 5, which means its factor would be x minus 5. Okay, so they tell us that the leading coefficient is 1, so I have f of x equals, now you can write the 1 or not, that's up to you, and then we just list all the factors, and they can be in any order, it doesn't really matter. The only thing that does matter, please, is make sure that that x minus 2, that quantity is squared. So you just want to be careful of that. So then here is your equation in factor form. Okay, so part B wants us to write the same equation, but in standard form, which means we have to multiply this all out and put it in descending order of the powers. So, again, I know that the 1 is not necessary, so I'm going to just disregard that for right now. So I essentially have 4 factors here. I have the x plus 3 and the x minus 5. You notice I rewrote those. And then I have x minus 2, but I have it twice, so I rewrote those here. So what I'm going to do is I'm going to double distribute over here. I'm going to double distribute over here. And then those answers, I'm going to double distribute again. Okay, so here we go. So let's start by doing that. So that x times x would give me x squared, right? Then I would get minus 5x. Then I would get plus 3x. And lastly, I would get minus 15. So I'm going to just simplify that and add my like terms. So that's going to give me x squared minus 2x minus 15. All right, let's move over to the right side, do the same thing. So here I'm going to get x squared. Here I'm going to get minus 2x. Here I'm going to get another minus 2x. And here I'm going to get plus 4. So let's simplify that. So that's x squared minus 4x plus 4. Okay, so now I'm going to take this factor and this factor, and I'm going to distribute those. All right, so I'm going to kind of try to go carefully, and hopefully it won't look like a mess, but I'm going to take this x squared, and I'm going to multiply it by that x squared, by that negative 4x, and then by that plus 4. Okay, does that make sense? And so I'm just going to do one at a time. So that's going to give me, let's start by the fact that that is going to be f of x, okay? And that's going to give me x to the 4th. Then that's going to give me minus 4x cubed. And what's that going to give me? 4x squared, right? Okay. Now, next, I am going to multiply the second term here by everything on the right side. Okay? All right. And let's see what we get there. So I'm going to get minus 2x cubed, right? Then I'm going to get plus 8x squared, and then I'm going to get minus 8x. All right, lastly, I'm going to take the negative 15 and I'm going to multiply that by everything in the second set of parentheses. All right, and then that is going to give me, I'm going to try to squeeze it in here, negative 15, and I don't think I'm going to be successful, x squared. And then I'm going to just write it up here, I'm sorry. I will get, what, positive 60x, and then minus 60, right? Okay, so now what I have to do is I have to kind of look through carefully and add my like terms. Well, the only x to the 4th I see is that very first one, so there we go. All right, so then let's look at x cubed. I see a negative 4x cubed here, and I see a negative 2x cubed here. So that is going to give me negative 6x cubed. All right, so now let's look at the x squareds. I see a positive 4x squared and a positive 8x squared. So that gives me 12x squared, right? But there's a negative 15x squared here. So that, I'm going to repeat again, 4 plus 8 is 12, minus 15 is negative 3, right? So negative 3x squared. All right, let's look at the x terms now. So let's see, I have got a negative 8x, and I've got this positive 60x. So essentially I'm going to subtract those two, right? And that'll give me a positive 52. Am I doing my math right there? So that's going to give me a positive 52x. Okay, and lastly, the only constant I have is the one at the very end, so that's going to be minus 60. So now, if we look at this, we see that this is in standard form because my powers descend. 4, 3, 2, 1, 0. Okay, so that's what it's asking, is writing our answer in standard form. There you go. Part A asks you to solve algebraically, so I'm going to start by factoring. Oops. So how about we start by not moving the paper all over the place, right? Okay, so I would start by saying, well, I can do my AM. So what adds to negative 3 and multiplies to negative 4? First of all, I look at my first term and I see that the highest power is x to the 4th. So I'm going to split that up to x squared and x squared. And I know that 4 and 1 multiplies to, sorry about that, to 4. And I need it to add to negative 3, so that's going to be a minus 4 and a plus 1. Okay. So I see that x squared minus 4 is dots, so I'm going to keep going with that, x minus 2x plus 2. But I see, however, that x squared plus 1 is not dots because I don't have the difference of two perfect squares. I have the sum. So it asks me to solve. So on the left, I'm going to get x equals 2. There's one solution. In the middle here, I'm going to get x equals negative 2. Let's make that look like a negative 2. There's the other. And then with this last set here. I'm going to set that equal to 0, bring over that 1, and then I know that I need to take the square root. Now remember, when you take the square root, don't forget, you need a plus or minus there. So x is equal to plus or minus the square root of -1. Well, remember that the square root of -1 is really just I. So then my answer for this side here is x equals plus or minus I. So I have two real roots, and then I have two imaginary roots. Okay, so the real roots being 2 and -2, and the imaginary roots being positive and negative I. Now, part B is asking you to draw a sketch, so I just throw that right into your calculator and your y equals, and I would just look at the picture. Okay, so if you look at the picture, I'm just going to draw kind of an ugly sketch here, sorry. But that's what your picture looks like. Okay, so we have our real roots right here at -2 and +2. And then the portion of the graph down here, okay, right here, does not intersect the x-axis. Those would refer to our imaginary roots of positive and negative I. Okay. Now, if you look at part B, it asks what are the zeros. So zeros, by definition, are where your graph hits the x-axis. So our zeros would be at x equals 2 and x equals -2. Okay, so this is for part B. So let me just kind of reiterate. Part A wanted you to solve algebraically. So our solutions are x equals 2, x equals -2, and x equals positive negative I. However, in part B, they want to know what the zeros are, and definition of zeros is where the graph hits the x-axis. So that would be at -2 and +2 as well. X equals positive negative I would not be zeros. They would not be zeros because they don't hit the x-axis. Which leads me into part C, and part C asks, are solutions to the polynomial equation p of x equals 0 the same as the zeros? So we would say, no, they're not, okay, because zeros are where, sorry, this is sloppy, p of x hits the x-axis. Now, solutions contain the zeros, but also include imaginary solutions. Okay, so solutions, they do contain zeros, but also contain imaginary solutions. And if you think about it, it's these imaginary solutions that do not hit the x-axis. That's why they're not zeros, okay? Which do not sorry, this is so sloppy, hit the x-axis. Okay? All right, so if you read the question, they're basically trying to determine if what we have right here is equivalent to what I have right here. I'm going to take all of these out of the radical form. So I'm going to do power over root with all three of them actually, and just see what I get. So the first one, if I do power over root, my power is 2, my root is 7. And that's going to get multiplied, okay, by the power, which is 3, and the root, which is 5. And they want to know if it's equal to x to the power over root. All right, well, I know that when I have two base numbers, or two bases that are the same, we take this exponent and we take this exponent, we're going to add them, right? Okay, so we keep the base and we add the exponents. So I'm going to keep that base of x, and I'm going to add 2/7 plus 3/5. Okay, so I'm going to start by finding a common denominator. Really, honestly, guys, you could do this in your calculator, but I see I have a common denominator of 35. So, and again, you can do this in your calculator, just 2/7 plus 3/5. And I'm just old-fashioned and old. So that's what, let me just show you. 2/7, the equivalent is 10 over 35, and 3/5, its equivalent is 21 over 35. And again, I'm just adding because keep the base, add the exponents. And I want to see if that equals x to the 6 over 35. Well, I can see right now that's not going to work. So if I add those, I'm going to get 31 over 35, which certainly does not equal 6 over 35. Okay, so the only way that Kenzie would be correct is if this fractional exponent was equivalent to that fractional exponent. So justify my response algebraically. This is my algebraic response. You can write a sentence if you want. I would say that she is wrong because x to the 31 over 35 does not equal x to the 6 over 35. When you're doing justifying, you can show the mathematical work, which is what I did. So you don't need to go into more detail than what you have here as far as the justification is concerned, because all the work's right up here. When I do these questions, I do see that it says explain, which means we have to explain much more fully than in number 16, and I have to use words. But I still like to do it mathematically because I think sometimes for most kids it makes it a little bit easier to explain. So I see that I have a power to a power here. So I know that I should multiply those exponents. So that's going to give me 3 to the 2/5 power, which equals the 5th root of 9, so we hope. Okay, so what did I do? So what I did was I multiplied the power 1/5 with the power of 2 and got 2/5. All right, so I'm going to actually number these steps so I know what I did. All right, second. Then what would I do? Well, I would look at this and I would say it wants to know if it's equivalent, or to explain how it can be written like this. So this I do not want to change. So I want to try to make 3 to the 2/5 look like that. So I'm going to do power over root here. So I'm going to take the 5th root of 3 and then square. Okay, so actually, let me write that. So I'm going to take the 5th root of 3 and square the 3. All right, so this is what I mean by that, so watch. So it's power over root, there's the root, and I put the 3 under there, and then I'm going to square. Now remember, with the square, there's two places you can put it. You can put it right under here, or if I were to put parentheses around this entire thing, I could put the square out here. Okay, but think about this. I eventually want what's under here to match what I'm going to have here. So I want this thing to become a 9. So the easiest way to make that become a 9 is by putting the squared underneath. Because then, what's 3 squared? Okay, so then the last thing I do is I raise 3 to the second power and get 9. And then watch what happens. Voila. Math magic. Everything checks. Okay, and then you've got a whole nice written explanation. So this one asks you to solve algebraically. So I started off by taking the second equation and just solving for y. So I have a y value that is 3x minus 3. So then I'm going to take the first equation, which is 9x squared plus, and now I see that I have a y. I'm going to take that and write 3x minus 3, but it is squared. So remember, when you have a quantity that's squared, it's the same thing as writing that quantity twice. And then we know that this is equal to 9. Okay, so now let's double distribute. And I'm going to get 9x squared. Oops, we should make that look like a 2, huh? Minus 9x minus another 9x plus 9. And then I am going to take this 9 right here and bring it over to the left-hand side. And when I do that, that is going to have to get subtracted. And we set that equal to 0. Let's just try to keep that off to the side. All right, well, if I look at this, I see I have a couple of things here. I can get rid of those 9s, right? Because they are like terms, but they're opposites of each other, so they'll cancel each other out. And I have 2 9x squareds, oops, which is going to make, turn that into blue again, 18x squared. And I have 2 negative 9x's, so that's going to make that minus 18x equals 0. So I see that I have a GCF of 18 and x, so I'm going to take that out, and I'm left with x minus 1. Now we're solving here. So I'm going to do my little t-chart, and I'm going to set each of these factors equal to 0. And so over here I have x equals 1, and over here I have x equals 0. All right, now I need to find the y value though, right? So I'm going to go back to what y is equal to. And if we look right over here, here's what y is equal to. And I'm going to plug in my x values one at a time into that equation. So I have y equals 3x minus 3. And let me write it over here also. Y equals 3x minus 3. All right, so let's plug it in. So I have y equals 3 times 0 minus 3. And over here, I have y equals 3 times 1 minus 3. Okay, so over here, I'm going to get negative 3, right, because 3 times 0 is 0. And over here, I'm going to get 0 because 3 times 1 is 3, and then 3 minus that 3 is 0. All right, so last thing is we want to make this look pretty. So I've got 0 comma negative 3 as one of the solutions, and then 1 comma 0. And then these are your two answers.